All right. So we are gonna go through the bell work, and we're gonna see if you guys have questions you want to work through on the review, and because we got a test coming up tomorrow. Tomorrow's the test. Okay, so we're starting out by looking at this bell work. Still part of the same stuff, and I want to know if these four expressions here are polynomials or not polynomials. What do we think for A? Is this a polynomial or not a polynomial? Hang on, I can't hear you. Say it again. It is, yes. This one is a polynomial. What degree does it have? Our degree is our biggest exponent, so our degree here is 4. Degree of 4. What about for B? Is this a polynomial? Why not? Yeah, we've got a letter in the radical. That's our problem. What about for C? What do we think there? What do we think on this one? What do you think? Why?
Because there's a negative exponent.
There's a negative exponent here. If I was to switch this around to make it so it didn't have a negative exponent, I would be able to write this piece as 6 times 1 over x, or 6 over x. And in our polynomials, we are not going to have variables in the denominator. So that means we also do not have negative exponents. So no, this is not a polynomial. And how about D, the last one? What do we think on that one? Why not? More than one variable. We're only dealing with polynomials in one variable, at least in this chapter. More than one variable. We're really only going to have like one instance where we see more than one variable in anything. Okay, so this is not our polynomials in one variable. So we are not going to do anything with that one right here. Okay. Questions on these things? Okie dokie. So what I have here is I have the entirety of the chapter review. And we can work through any problem you guys want. We do not have time to do the whole thing. But we can do anything that you want in here. And by 5th period today, I will get the answer key posted. I just don't have it posted yet. Mostly because I forgot to take it home, so it's not been written yet.
What?
I haven't written it yet. I didn't take the paper copy home. I forgot. And I wasn't going to print it off at home. And I didn't bring my iPad, so I couldn't do it digitally either. So, I'll get it posted during 5th period today. Are there any questions on this review you would like to go through? 5. It's very much like what we just did in the bell work. Boop. So is it a polynomial? That is 100% what we just did in the bell work. These other ones are just specific polynomials. So quadratic, these guys are our parabolas. So these would be that our degree is 2. It means we'd have x squared as our biggest term, things like that. So that's what makes something a quadratic. Our linear, what word do we see in linear? Line. These are lines. So these will have degree of 1. usually as like an mx plus b situation. Not necessarily always, but a lot of times. But the power is 1 or 0, because that would be a horizontal line. So our degree would be 1 or 0. So let's take a look at these. Are there any that we spot off right away that are polynomials, quadratics, linear, or none? Which one? A is linear. Yes, it is. It has a degree of 0. That just means it's a horizontal line. That would be, there we go, L. Degree is 0.
D.
What about D?
It's a polynomial.
Yeah. D is a polynomial because it does have all the valid things. Like I don't have any negative exponents. I don't have any letters in the denominator. I don't have any radicals or anything crazy going on. So this is a polynomial. What is the degree on this polynomial? It's a degree of 5. So it's not a quadratic because quadratics are a degree 2. It's not linear. It's not because it's not degree 1 or 0. So it's just a polynomial. All right, what about some of these others? F is a quadratic, yes. So I'm gonna put a Q. Because our biggest power is a 2, and everything else meets the rules. Everything else follows the rules.
C is none of these.
C is indeed none of these. Why? Because there's a variable in the radical. This guy's my problem. So it's none of those.
And then E is also none of these.
E is also none of these. Why?
Because there's an X in the denominator.
Because there's an X in the denominator. None. So our last one is B. Why? Because it's a degree of 1. So our B is also linear. Again, this has an exponent of 1 here. That's an mx plus b situation. It's just mt plus b. So linears have a degree of 1 or 0. The zeros are just horizontal lines. It's just y equals 2 kind of vibe. Okay, so that's all we're looking for there. We don't have to do tons and tons and tons with that one. All right. What else do you guys want to work through? Don't get to pick.
Can we do 10?
10. Let's look at 10. Boop. Ah, the boxy one. Boxy box. All right, so we've got Miko or Miko. We don't have a pronunciation guide, so I'll go with Miko.
Probably Miko.
Miko feels right looking at it, but if you know someone with this name and goes by Miko, it's not wrong. Correct me if I pronounce things wrong. I 100% admit to being really bad at pronouncing stuff. All right, so we are asked to figure out the volume of this really random box that she's making that is scalable to the size of her products that she's selling. So she doesn't have actual dimensions. She's got the vibe of dimensions, basically. So what I have here is I have a length, I have a width, and I have a height, right? Define volume. We even gave you that part up here. Length times width times height. So we're going to take our length. which is that 3x minus 1. We're going to take our width, which is that x plus 2. And we're going to take our height, which is the x. And we are going to go multiply this two together and then multiply that one together. So it makes it polynomial multiplication. What? Oh, it is. Not on purpose. It's just those are like the three colors I picked because they have a nice contrast, but also they're not difficult to read. So my purple's a little dark for that. All right. So we're going to take and multiply these guys together. I'm about to have to introduce new colors. So how I do. I'm going to start with the first two pieces. I'm going to multiply these guys together. I'm going to do it very, very early. I'm going to have my 3x times x, giving us 3x squared. I'm going to have my 3x times 2, giving us a plus 6x. I'm going to have my minus 1 times x, giving us a minus 1x. And I need a color I haven't used yet. There we go, this one. Minus 1 times the 2 to get a minus 2. And then we've still got this x just kind of chilling over here. So break it into smaller pieces. This is just a polynomial multiplication with a vague sense of plot. It's got a whiff of plot. That's it. So then we're going to combine our like terms before I do my last set of multiplication because I don't want to have to deal with it when it's 4. So we're going to have our 3x squared plus 6x minus 1x. Minus 2. And that's all still being multiplied by an x. What am I going to do with that x? Yeah. If it was written out in front, it'd be way easier to see that this is just a distribute thing. It's just written on the wrong end, but that's okay. We can do that still. We're going to have our 3x squared times x, giving us 3x cubed. We're going to have our 5x times x. We have a 5x squared. And we have a minus 2 times x to get minus 2x. And that is as simplified as we can go. That's our guy. That's a little opaque, but that's okay. That's our answer right there. Which one? 11. Yeah, we can look at the next one. Okay, any questions on this one before we look at the next one? Cool, cool. Let's look at 11. Determine the quotient. Fancy schmancy talk for divide the thing. So when we are given our division problems, the way we decide what to do is we look at what we're dividing by. So in this case, I'm dividing by this 3x squared. So this guy gets to make the choice of what we do. What can we do to divide by a single chunk like that?
Split it up.
Split it up. Cut my math into pieces. I'm going to divide. This is where we cut it apart into separate pieces. Every place we have an addition or a subtraction, that's where I split it apart. We're going to uncommon this denominator. So we're going to have our 81x to the 8th, and we're going to put it over its own copy of the denominator, 3x squared. Then we're going to have our plus and a new baby fraction with my 36x to the 5th over my 3x squared. And then we have our minus sign, and we're going to have our 27x squared over the 3x squared. So whenever we're dividing by a monomial, that's what this guy is. He is a monomial. We're going to split it up into separate fractions so we can simplify each one individually. Because we look at each guy individually. So if I have 81x to the 8th over 3x squared, How is this guy going to simplify? What's up? If there's no adding or subtracting in the denominator, that's how we know if it's a monomial or not. So if this was like 3x plus 1, then we'd go a different direction. We'd be looking at either our long or synthetic division. An easy way to remember that is if you look at this and we tried to figure out a root to do like synthetic division, we'd get 0. And we can't really do synthetic division with a 0. All right, so let's look at each of these guys individually. 81 x to the 8th divided by 3x squared. What is our 81 divided by 3?
27.
So this becomes 27. And x to the 8th divided by x squared. How many?
To the power of 4.
Not quite. Remember, think about x to the 8th being 8 x's multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. And we're dividing it by x squared. 1, 2. Yeah, so we're going to have 1, 2 of them that cancel out. How many x's do we have left? 6. So x to the 6th. So when we divide the whole piece, we subtract those exponents. So 8 minus 2. Oh, I'm knocking stuff over here. Right. How about on our next piece, that blue one? 12x to the 3rd. Very similar process. 36 divided by 3. X to the 5th over x squared. That's 5x's over 2x's. So 2 of them are going to cancel out, and we're just left with 3. And then what do we get on the last one, on the green one? 9. What happens to my x's?
They cancel out.
They both cancel out. Okay. Is there anything else we can do to simplify this or combine any like terms or anything?
Greatest common factor.
We're not being asked to factor here, but I love the enthusiasm. Because we could. Like, it does have greatest common factor we could pull out. It would be 3. But we don't need to factor that, so. Throw down a gauntlet, but that's our answer. We'll get more into factoring stuff in the next chapter. We'll get back into factoring crazies.
That totally doesn't scare me slightly.
We'll get there. I promise. We'll be good. We'll be working with these guys more. The next chapter is basically continuation on this one. Yeah, let's look at 12. Let's do a long division. And then we can probably also go straight into like 13 or 14 to look at one of synthetic divisions, because it's good to remember both of those. So this one does specify for us to use long division. So we do need to make sure we do our very best to follow the instructions there. If we, like when it comes to the test, if we genuinely forget how to do one of the techniques and you can do it with the other one, I would rather you have an answer with the wrong technique than leave it blank. So totally fine, like you'd still definitely get points. But just, I would prefer you use this one to get all your points. Okay, so our long division, that's when we set up the full like 3rd grade long division house. Okay. I don't know why I'm doing it in purple, but I am. That's a choice. All right, so then we're going to have our first piece goes inside. Because early bird gets the worm, so he gets to go inside the house. 5x squared plus 17x minus 13. And we're dividing it by the second guy, that x plus 4. So when in doubt, we're going to start by setting it up. So what we need to do is we need to look at our first terms. So I'm going to start by looking at my 5x squared and my x. What do I need to multiply this x by to make it be exactly 5x squared? 5x. That's what goes on the top. I need those two things to come together to make exactly this. Because our next step is to do exactly that. We're going to take our 5x times the whole factor. So I'm going to have my 5x times x, which gives me that 5x squared we were aiming for. And my 5x times that plus 4, which gives me a plus 20x. That's an x. There we go. I'm going to erase the little lines there because they get in the way. And then since it's long division, we subtract everything. So we're going to have our 5x squared minus 5x squared, which gives me 0x squareds, which is what we expect to happen. That first term should always go away. And then we have 17x minus 20x. Ew. That would indeed be negative 3x. I don't like it either, but that's okay. We'll get there at the end.
So we do put x?
We do put the x, because it's 17 apples and I'm giving away 20 apples. So I have a debt of 3 apples. I owe 3 people apples. All right, so then we need to drop down our next piece, because I want to make sure I have all my guys down here. So we're going to drop down our 13. We had to kind of figure that one out. The 5x on the top. The way that works best for me, but this is again just me, as I take my x times what equals that 5x squared. That's the way my brain likes to do it. I also know a lot of people that like to do it as 5x squared divided by x and get it that way. Either way, we should come up with that gray 5x. That's where we're getting that from. We're making up that piece. We have to figure that piece out. Either way, those are both valid. My brain tends to go this way. Everybody's brain's going to be a little different. Stop.
You always bring down the second number, the negative 13?
Yes. We will always need to bring down the next piece. We also made, like, if we have more pieces, you can always bring all of them down. But we need to make sure we have at least as many pieces here as we have pieces here. So since I have 2 guys over here, I need to have at least 2 guys here. If I do not have enough guys, we either have a 0 term somewhere in here, like 0 x's or something like that, or we're at the end and that's a remainder. All right, let's look at the next round, because that was cycle number 1. We get to do the whole thing again.
-3.
Because I need to take, no, what does, I'm going to get myself a little barrier, changing colors 12 times here. I want to know my blue x times what gives me that minus 3x. Or again, you can think of it as that minus 3x divided by x. Either way, thank you, sir. Boop. Either way, we should wind up with a minus 3 as our next piece, right? So just like we did on the first one, I'm going to take this minus 3 times the whole guy over here. So we're going to have our minus 3 times the x, and we get our minus 3x. And we have our minus 3 times the positive 4 to get minus 12. I know, it's icky. I'm sorry. Ew. Called I didn't write it. Write it fixed it for us. I didn't write it, or I'd have fixed it for us. It's okay. Good practice for us. So we have our minus 3x minus negative 3x. Because we need to make sure we subtract here. You can think about this like our polynomial subtraction, where I distribute the minus sign through. You can absolutely do that to make this guy be plus and this guy be plus. If that helps you, you could do that. The 3 times the 4. So our minus 3x plus 3x It's going to give us 0 x's. That's what we want. That first term should always 0 out. And I have minus 13 plus 12. What is minus 13 plus 12? We don't have any more pieces to bring down. So this guy's a remainder, which is u. All that does is we can write that if you have a remainder, which can happen sometimes, mostly if we make a mistake on stuff. But if you wind up with a remainder, it's a great idea for us to be able to know how to write it just in case so we can finish the problem out. And the way we do that is we take our leftover bit and we put it over what we were dividing by to make a little baby fraction. So I'm going to get rid of that. So we take our remainder of that minus 1. So I'm going to have my minus 1 over what we divide by, x plus 4. And then we drop our pencils, turn around, walk away, and go, ew, I don't want to see you again.
X is in the denominator.
Which means this is not a polynomial answer, which means it didn't go in evenly, which means we're not going to have to deal with that again for any other steps. Because now it's not a polynomial, so we're kicking them out of polynomial club. Pfft. We don't want to play with you no more. It was a polynomial here. This guy's a polynomial. This guy's a polynomial. Our answer is not. It gave us an icky. Ew. We should have, on the test, we should wind up without remainders, I believe. As far as I'm aware, we should wind up without remainders. But just in case we have any mistakes, if we see them, it's nice to know how to write it in case we run into those. I am 99% sure, unless I typo to typo, that we should not have any remainders, and I will double, triple check stuff. But if you wind up with one, so that you don't have to panic, erase, and go back, or leave it blank, stop leaving things blank, this gives us an option, okay? Yep, if this had been 12 and we got a 0, we just would not have this piece here. And if I'd noticed it, I'd have changed it on the review. Say it again.
What did you do with the first three x? You just wrote the 3 left there down.
Oh, for this orange row?
Yeah.
Yeah, I took the minus 3 here. It was, let me get my orange real quick. Orange. This guy here, I multiplied it times the whole piece over here, just like we did for the yellow. And that's what gave us this guy down here.
Can we do 13?
Hang on a second. I'm going to get rid of these pluses. Oops, that was a minus. Like that. So we took our minus 3 times the x to give us minus 3x. And our minus 3 times the positive 4 to get our minus 12. And then we have to subtract the whole thing. So you can either do it as -3 minus -3, totally works, and you can type it in the calculator, or you can think back to when we did our addition subtraction where they were all next to each other, and we would distribute the minus sign through. That's totally valid. We can do that to make them pluses. Yep. I think that's a wonderful idea. That gives us a practice on the synthetic, I believe, but then I just turned the page and lost entirely track of what we're on. You said 13? Cool. All right, so we are dividing this polynomial, and we are given a factor. So we are asked to divide x cubed plus 5x squared minus 22x minus 56 by this guy, x plus 7. So the first thing we're asked is what number is going to go in the box? How do we know it's going to be -7? To figure out what goes in the box, we take that x plus 7, the thing we're dividing by, or the factor we're given, and set it equal to 0. Subtract 7 from both sides, we get x equals -7. That gives us a root. That's the guy that goes in the box. What are the numbers that we're going to put over here? 1 from the x cubed. 5 from the x squared.
-22.
-22.
And 56.
And -56. gonna leave myself a little bit of space and then I'm gonna draw my line. So that's how we set it up. I am 90% sure that there's a question where all you have to do is set it up and it says you do not have to solve it. Or at least there was at one point. That may have been on a homework. I might remember that wrong. I think it was on a homework. I just know we did that at one point where you just had to set it up and you didn't have to finish it. That's okay. Just know that if you have one where we say all you have to do is set it up and you don't have to finish it, there is likelihood that it has a remainder. So don't let it freak out. But this one, it does not say to just set it up. We're going to finish it out because it's a great idea to finish it. Oh, I'm going to put my little answer in the blank just to tidy things up. We put -7 in the box. What do I do for the process of our synthetic division here? What's my first step? Drop it like it's hot. What's going to go here? -7. We take the 1 times the number in the box and we put it under. So we're going to have our -7. What do I do next? It's going to go here. Because we add these guys together. 5 plus -7 or 5 minus 7, we get -2. Which means what's going to go here? +14. We've got -22 plus 14. -8. Oh, we have our -8, which means what's going to go here? A +56. And our remainder is going to be 0. How do I write this with its letters back? My 1 is going to have what term with it? X squared. How do we know it's an x squared? It goes down 1 degree. This was an x cubed, so now my first term is going to be an x squared. It goes down by 1. And so my next term is going to be an x, and then this guy is just a number. So as a polynomial, we have this as our 1x squared minus 2x minus 8. And then we're going to follow our instructions and write it as a times x plus 7. Because if we took our 1x squared minus 2x minus 8 and multiplied it by x plus 7, we would get exactly the x cubed plus 5x squared minus 22x. And I'm right on the edge of the screen. Minus 56. It fits. Kind of. Okay, that's what they mean by write it as a product. I'm not going to be super petty about that, but they want us to see that. You can also look in here and see if it'll factor further. To see if we could X and box it. We only have like 2 minutes here, and I genuinely do not recall if this one factors or not. Multiplies to be -8, adds to be -2. Yeah, it'll factor. So if it said for us to find all roots or find all solutions or to factor fully, like it does on OSA number 14, like where it has those 3 blanks, we're going to have to factor our what's left over. So real quick before the announcement bell, I want to show a difference real quick between how we have this piece here, where we gave you a factor, and on number 14, where we don't give you a factor, what we give you is the root. So we're giving you the already solved piece. When we give you a root, that's telling us exactly what goes in the box, -1. So what would the factor for that piece be? If I wanted to go backwards and write it like the one in 13, how would I get the factor? For,
Plus one.
Yeah, so to get our factor, it would either be like x minus -1, that guy, which is the same thing as x plus 1. So that's one of our factors. After that, it's the same process we did on the last one. I just wanted to kind of point that out since we were right here with it. Okay? Again, I will get the answer key posted during 5th period today. I just don't have it right now. But we gotta do announcements. Boop, boop, and boop. Announcements.